I caught one again. I'll get both tomorrow. Hey, one of my favorite lessons of all time, factoring trinomials where a equals 1. What does that mean? A is the coefficient of the squared term. And we always have that in a trinomial where we say if it's in the form x squared plus x plus a constant, the coefficient of x squared is a. Okay? So we've got, I don't know, let's just put like a number. This is A. This is B. And we call that guy C. Okay? So if A is 1, these are easy. It's like a puzzle, and I love puzzles. So all you have to do is figure out the two numbers that multiply to the last and add to the middle. Okay? So let's write out a set of binomials that when you multiply these binomials together, you create this trinomial. Okay? So n squared is n times n. That would be like the first part of the distribution, the first, the f and the FOIL. Okay? And then the last would be, well, what multiplies to get 10? You could do 2 and 5, or you could do 1 and 10. I like to keep a list of factors over here for things that multiply to 10. Sorry, it's not a t-chart, we're just doing it like that. So it could be 1 times 10 or 2 times 5. Now, using one of those factor groups, you have to make negative 11 in the middle. Well, you can't do that by adding 2 and 5 together, but you can do it by adding 1 and 10, negative 1 and negative 10. So 1 and 10, and you heard me with the signs there, negative 1 and negative 10 makes negative 11. But when you multiply the same two numbers, you get positive 10. Okay. All right, it's the reverse. Factoring is the reverse of multiplication. We multiplied binomials already. We multiplied polynomials. So now we are factoring back to where we started. Okay. This becomes this. Interchangeable. Nice. Let's go down here. We want two numbers that multiply to 12 and add to positive 4. Okay. So that middle part is the one we're going to focus on in a little bit. Right now, you just look at the ends. So you go n squared is n times n. Since a equals 1, see this? 1, 1. These are pretty straightforward. Not too bad. And now we look at the 4, just like we looked at the 11, after we do the factors of 12. Could it be 1 and 12? Could it be 2 and 6? Could it be 3 and 4? What's your choice? How are you going to get 4 with one of those factor groups? By addition and subtraction of those integers. 2 and 6. Okay. Because you can add 6 and subtract 2, and then you get positive 4 in the middle. So if you want to, oh, there's a computer there. Hi, buddy. How you doing? Let's move you over. If you were to redistribute this, okay, real quick, n times n is n squared. N times 6, I'm using the distribution method, is 6n. Negative 2 times n is negative 2n. And then negative 2 times 6 is negative 12. Add your like terms in the middle, and you end up back where you started, which is right there. Okay? All right, let's move along. Number 6. I got a little song for you. If your trinomial has two positives or addition signs, I say a plus plus here, a plus plus there, here a plus, there a plus, everywhere a plus plus. Hold it. Sorry. I'll stop. B squared is b times b. You need two numbers that multiply to 64 and also add to 16. Some people, this will just jump out, right? You're like already writing it down and you're waiting for me to move on. Others, it takes longer to process and think, okay, what are those two numbers? It doesn't hurt to write out the factor groups starting with 1 and 64, even though you know that's not going to be possible. These two numbers have to add together to get 16. A is 1, you're trying to get 16 with factors of 64. Okay? I'm going to go ahead and write them all out. 2 and 32, 4 and 16, 8 and 8. There it is. 8 plus 8 is 16. Now, this one's a bit special. See how we got the same binomial twice? When you're multiplying the same thing times itself, you're allowed to use an exponent. So I would prefer that you finish this by saying b plus 8 squared because you're multiplying that binomial times itself. Okay. So that's the best way to finish that. Let's go to number 8. Two numbers that multiply 24 and add to negative 4. A is 1. Nice. factor groups of 24. So you look here now, and we're going to try to have the goal of -4 when we get done. So 24, let's see, 1 and 24, probably not going to happen. 2 and 12, I can't get -4 with 2 and 12. 3 and 8, don't forget 3 and 8. Nope. 4 and 6, I cannot add 4 and 6 to get -4. It's not factorable. There are no factor groups. There's nothing you can do to add these numbers together to get -4. So no, and then you would just say not factorable. I cannot do it. That must mean there was no two binomials that you can multiply together to get that. Number 10. Plus here, plus there. Write them down. A squared is A times A. You should be able to breeze through this one. Two numbers to multiply to 18 and add to 11. 2 and 9. Can we move on? Okay. And the last example for today. N squared minus 5n plus 6. So I don't know if we had this combination of minus plus. Well, we did here, but it didn't work. Oh, back at the beginning. See how it was minus plus and it turned out to be minus minus? Or subtract, negative, negative. Same thing's going to happen over here. Anytime your trinomial has a negative followed by a positive, it always has to be minus, minus, or negative, negative. Okay. N squared is n times n. Two numbers that multiply to 6 and add to -5. You're limited on your choices here. You could go 1 and 6, or you could go 2 and 3. Make your decision right now. I'll wait. Have you made it? A lot of people choose 1 and 6 because they think, I can get 5 with 1 and 6. I can go 6 minus 1. But that's not what we're doing. It has to be subtracting both numbers. If you do -1 minus 6 and you add those two together, you get -7, which is not your goal of -5. Okay, sorry, I forgot to do that on this one. So no, you can't use the 1 and the 6, but you can use the 2 and the 3. Okay. -2 plus -3 is -5. That works. Wrong cap. There we go. Lightsabers, again, we did that last week. Every Star Wars has a sequel, baby. Where's my lightsaber? This one never works. You stole my lightsaber! You stole my couch! Hey! Easy! Oh, it's fake. Number 17.